Alright, good people, this is section R-2, the review chapter, second section, integer exponents, scientific notation, and order of operations. So, before we get started, I just want to remind you that here, when you listen and when you come up with questions, of course, because you're all actively listening and you're all actively thinking about it, and of course that's going to produce questions, regardless of how great of an explanation I have. Maybe you require something different, or maybe something comes up that your last teacher last year said something differently, or whatever it is. There's going to be questions. So go ahead and write down your questions there. You could say, I have a question about number 17, like why is it purple? And something like that. Just bring your questions to class, and that'll be awesome. Also, make sure you do. I'm going to make sure that you're listening, because I've had students in the past who just watch and they don't use their headphones or they don't play the audio, so I want to make sure you're listening. And so I'm just going to drop some personal information, like, for example, my favorite animal is the leafcutter ants. If you're listening right now, and I know all of you are, go ahead and write down Bergman's favorite animal, which is the leafcutter ants. And we'll talk about that in class. Maybe you can tell me your favorite animal, too. That'd be awesome. All right, so here we go. Rename with exponents. So exponents look like this. If you got 8 multiplied by itself 4 times, then you can say that that's the same thing as 8 to the 4th. This is the base. That's what we call the base. This is the exponent. And then the whole thing together is what's called the power. Alright, so x times itself 3 times, base, exponent, there's the power. Moving on, 4y times itself 4 times, that would be, you would have to use parentheses to encapsulate both the 4 and the y, so you've got 4y to the 4th. That's it. Rename without exponents, looks like this, 3 times itself 4 times. 5x times itself 4 times. 5x, use parentheses. 5x, 5x, and 5x. Negative 5 times itself 4 times. Now notice, actually, check out this. The next 2 problems are going to be very similar. One has parentheses and the other one doesn't. When you have the parentheses, that means you're including the negative 5 as something that needs to be repeated. Negative 5 times negative 5 times negative 5 times negative 5. Great. That's the answer. However, for number 7, since there's no parentheses, we take this to mean that the 5 gets repeated 4 times, 5 times 5 times 5 times 5, but the negative only gets included after the exponents. Negative 5 times 5 times 5 times 5. And it makes a big difference, because here, when you multiply all this out, you get negative 625 as the actual answer. But here, negative and negative cancel, these 2 negatives cancel, and because there's an even number of negatives, they all cancel out, and you're left with positive 625. So the difference between parentheses could mean the difference between whether or not the answer is positive or negative. Here, 3x to the 0, anything to the 0, is going to be 1, which is, I think, pretty awesome. Ask a calculator. Type into your normal calculator, pick any number you want, raise it to the 0 power, and you'll see that you get 1. I just think it's pretty cool, and I'll explain to you why in class if you want. 5y squared, let's simplify. That means 5y times itself twice. 5 times 5 is 25. Y times y is y squared. Simplified. 2x, negative 2x times itself 3 times. Well, you notice the parentheses include the negative, so we'll write the negative 3 times. And then we have to ask ourselves, what is negative 2 times negative 2 times negative 2? Well, 2 of these cancel, but we're left with another one. So it is going to be negative 8. And then there are 3 x's, so we say negative 8x cubed. Rename 1 over 4 to the third using a negative exponent. Well, I'd like to just remind you that the negative exponent rules has this relationship between negative exponents and fractions. I can show you why in class later if you want, but the relationship is there. And I think to summarize it, you just say, if you want to cross the line, then you change the sign. So if you want to cross this fraction line, like if you want to bring it back up, then you have to change the sign. 3 becomes negative 3, and it's 4 to the negative third. 4 to the negative third is the same thing as 1 over 4 to the third. I'd like you to do the same exact thing with 10 to the negative fourth. And show me what you come up with. Write 3 other symbols for 4 to the negative third. Well, you can turn it into a fraction, and in order to change the sign, you can cross the line. So you have 1 over 4 to the third, which is now on the bottom. That's the same thing as, well, I guess we could like multiply 4 times 4 times 4, which happens to be 64. Or, oh yeah, you could change 64. You could cross the line and change the sign. 64 to the first power becomes 64 to the negative first power, changing the sign. And there's other symbols for this too, but here are 3 that come to my mind first. Multiply and simplify. So if you have exponents that you're multiplying, if the bases are the same and you are multiplying, that's a terrible. Then you can just add the exponents. Negative 3 plus 7. If you add negative 3 plus 7, you get positive 4. So this will be 8 to the positive fourth, because negative 3 plus 7 is 4. That rule gets summarized right here. If you have bases that are the same, and you're multiplying, then you can just add the exponents. Let's use that again. 7 plus negative 2 is 5, so that means you get y to the fifth. Here, we can multiply these two together and multiply these two together. 9 times negative 2 is negative 18. And x to the fourth, x to the seventh, let's see, 4 plus 7 is going to be 11. So this factor contributes 4 x's, this factor contributes 7 x's, so on total you have 11 x's. Negative 18 times x to the 11th. Let's do the same thing here. Negative 3 times negative 25 is going to be positive 75. Negative 4 plus negative 10 is going to be negative 14. Uh, 17, divide and simplify. Well, before we had multiplication, and that was add the exponents. Here we're going to have division and subtract. So this means 8 minus 5. And actually, if you write out all the different 4s, 8 of them, over 5 4s, then you can cancel 5 of them from both the numerator and the denominator. And that means you're left with just 3 4s. 8 minus 5 is 3. So the answer is 4 to the third. This is the long way, but if you want to do the short way, and in fact I need you to make sure you can do the short way, is you have to subtract. 8 minus 5 is 3. That's 4 to the third. Let's subtract again. Negative 5 minus 9 would be negative 14. So the answer is 10 to the negative 14th. Whoa, this is ugly. What a mess. Well, we can cancel out some things. 21 goes into 42 two times. And then here we've got a 7. We've got a 7 here and then an x10 here. So we can have 7 minus 10 and get negative 3. We also have 6 minus negative 3 to get 9. So that means we're going to have negative 2 x to the negative 3rd power y to the 9th power. Now, sometimes the instructions will say make sure you use a negative exponent, or make sure you use a fraction, or don't use a fraction, or don't use a negative exponent, but since it doesn't specify, then we can just leave it that way if we want. That's the quotient rule. This is what it looks like in general. If you have two exponents that are being divided, that means you can subtract the exponents. What about if we have a power raised to a power? The rule is going to say that we can power to a power, that the rule is going to say that we can multiply the exponents. And that makes sense too, because if it was 3/7 to the 7th power, it might look like this. 3 to the 7th written out 7 times, so you'd have to add 7 plus 7 plus 7 plus, 7 plus itself 7 times. It's just much faster to, let's not do it that way. Let's multiply these. 7 times 7, which is 49. 3 to the 49th. Multiply 2 times negative 7 is negative 14. So the answer is 8 to the negative 14th. Here, you can actually distribute the exponent to all three factors. So this becomes 4 squared, this becomes x to the negative 2 squared, and y 7th to the squared. And you can deal with each of them individually. 4 squared is 16. Negative 2 times 2 is negative 4. And 7 times 2 is 14. Oh, this looks messy. One thing I would say is that if you could, a good first thing to do would be to simplify what's inside the fraction first. But since we can't, since I don't see anything to simplify inside the fraction, then we can take all of these factors and raise them to the negative 3rd power, all of them. So that would be 3 to the negative 3rd, x to the 4th to the negative 3rd, y squared to the negative 3rd, over z to the 5th raised to the negative 3rd. So, let's take them each individually. In fact, I'm going to cross the line and therefore change the sign. This becomes 3 to the positive 3rd. X to the negative 12, y to the negative 6, z to the negative 15. Another step, 3 to the 3rd is going to be 27. Cross a line, change the sign. Cross a line, change the sign. Cross a line, change the sign. On the top we'll have z to the 15th, positive 15, x to the 12th, y to the 6th. There it is. Let's do the same thing here. I'm going to simplify the fraction first. Simplify what's inside. 10 over 5, that's a 2. Negative 4 minus 6 is going to be, negative 4 minus 6 is negative 10. Y to the 7 minus negative 8 would be positive 15. And z to the negative 2 minus negative 3 would be 1, positive 1. That's all raised to the negative third power. So now that we've simplified the fraction just a little bit, we can now raise each of the factors to the negative third power. And that gives us 2 to the negative third, x to the 30, y to the negative 45, z to the negative 3. I'm going to change these all to positive exponents. Sorry, I'm running out of room. In order to change the sign, I got to cross the line. It becomes 2 to the third, x to the 30. Change the sign, cross the line. Y equals y to the 45th, and z to the negative 3. Becomes z to the positive 3. One last thing that I think I need to do in order to make sure it's totally simplified is 2 to the third, which is going to be 2 times 2 times 2 is 8. X to the 30, z to the third, y to the 45th. Wow. There it is. Convert to scientific notation. Scientific notation looks like this. It's really good in science when we have to talk about really large numbers or really small numbers. And the thing you need to remember is that big numbers have a positive exponent, small numbers have a negative exponent. So I can just look at this positive exponent here and see that this is going to be a big number. Really big number, like, the number of miles between the Earth and the Sun, or the number of stars in the galaxy. These are really big numbers. The decimal starts out here, and if you want to move the decimal 1, 2, 3, 4, 5 times, you get 4.65 times 10 to the positive 5. 5 times, put the exponent of 5 there. Now, why did we put it specifically right there? It's because this number here has to be a number between 1 and 10. It could be anywhere between 1 and 10, not including 10. You can always move the decimal to create a number between 1 and 10. Like here, 1, 2, 3, 4. New decimal is at 1.45. Now this is a really small number. This is like how many millimeters, or how many millimeters wide is a cell, or something like that. Really small distance. So because it's a small number, I'm going to say times 10 to the negative 1, 2, 3, 4. I moved it 4 times, and so the 4 creates the 4, and because it's small, it's a negative exponent. That's the answer. Again, this is a negative exponent, so that means it's going to be a small number. And how many times do we have to move the decimal place? 5 times. In order to create a small number, I'm going to move it in this direction. 1, 2, 3, 4, 5. Decimal 0, 0, 0, 0. That is decimal notation. We've already said this is a really big number, so let's take 7.894 and make it really big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a lot of zeros. That's 7,894,000,000,000. A really big number. This video has gone on long enough, so I'm going to not do this one. You don't have to do it either. But I will, and I won't do this one, but I will do number 31. Okay, so if you're multiplying these together, you can multiply the numbers and multiply the exponents separately. So 8.3 times 7.6 is 63.08. Then 10 to the negative third times 10 to the negative 8, that would be negative 3 plus negative 8, which is negative 11. Negative 11. Now this is close to scientific notation, but it's not perfect because this number is too big. Here, we need a number between 1 and 10. In order to get a number between 1 and 10, I can move this decimal. So that becomes now 6.308 times 10 to the 1 times 10 to the negative 11. 1 plus negative 11 is negative 10. 6.308 times 10 to the negative 10. That is your answer. Please excuse my dear Aunt Sally. Always do parentheses first, exponents next, multiplication and division in the order that you see them, and then addition and subtraction in the order you see them. So here in this example, we do exponents first. We get 3 times 25 plus 4. Notice that I'm making one change and recopying in a vertical method, in a vertical style. I think this is the best way to do it. I'm not writing an equal sign. Don't write it. You don't need equal signs here. It's not an equation. 3 times 25 is 75. Make one change and recopy. And then 75 plus 4 is 79. Again, make one change and recopy, and then no equal signs are necessary. So I'm going to say that we've got a big fraction inside parentheses. I'm going to do what's inside the parentheses first. What's inside these parentheses is 3 plus 2, which is 5, squared, minus 3. I can do 2 squared, which is 4. 2 to the third is 8. 5, anything to the 0 is going to be 1. Then, my next step, I'm going to have everything to the third power. On the top, I'll see 25, and then I'm going to change this subtraction to the addition of negative 3. Negative 3 plus 4 is 1, plus 1 is 2. 8 plus 1 is 9. Let's keep on going. And everything is going to be to the third power. This is 27. That's a 3. 27 over 9, which is 3, to the third power. 3 times 3 times 3 is 27. That's the answer. Alright, we're done, and what I'd like you to do is, after you answer the Edpuzzle questions, I'd like you to start assignment R-B, review chapter, and the second assignment, which is, so we'll just call it B instead of A. Get out your composition book, write down the problem list and the new page, and then just try the first problem. After you do that, I'll see you in class.